This video is about measuring movement. First off, we'll talk about the difference between a scalar and a vector quantity. And measurements that have only a magnitude or just a number with a unit, they're considered scalar quantities. Things like speed or distance or length, it's just a number and a unit that tells you what that number means. When you graph scalar quantities, they look like just a line on a graph or a point on a graph. Measurements that have both magnitude and direction are considered vector quantities. These include things like velocity, displacement, trajectory. When you graph vectors, they're the same as scalar quantities, except one end will have an arrow that tells you which direction it's going. So the only difference between a scalar and a vector quantity is that a vector quantity has direction, a scalar does not. Distance versus displacement. A distance is what we would consider a scalar quantity. So when you're calculating distance, you look at the path an object takes, and then add up all the bits of that path until you get to the total distance covered. So there might be some detours that they go through. You might be out walking your dog and you just walk around at random and hope you make it back home. But whatever ground you cover, that is the distance that you covered. We consider that path dependent because it depends on what path you take, how far you'll be traveling. Displacement, on the other hand, is a vector quantity, and you only look at a snapshot of the start point and the end point for the travel. So in this case, you would calculate the distance between the starting point and ending point, or point A and point B. You don't worry about whatever path the object took to get from beginning to end. You just worry about the distance between the start and the end. So we don't consider that path dependent. You also have to include what direction an object would have to move if we're going as the crow flies from point A to point B. And that's what makes displacement a vector quantity. So for example, say someone started at point A here on this map, and they followed the red arrows. Maybe they're just out for a nice Sunday walk. And it asks you to calculate their distance and displacement. So if we start at A, you can see they went one block to the north, one block to the north, one block to the east, one block south, one block back west. That makes 1, 2, 3, 4, 5 blocks for the distance traveled. Displacement, on the other hand, you're starting at A and you end at B, so you only focus on how far it is between A and B. So that is 1 block, and you also have to include the direction, so it's 1 block to the north. When we calculate speed and velocity, it doesn't take very much. We just have to know the distance that was traveled, and we have to know how much time it took to travel that distance. If we have those two things, we can calculate the speed. Our equation, v equals d over t, stands for speed equals distance divided by time. So if you have that distance and you have that time, you just take the distance divided by the time, and that gives you the speed. If you want the velocity, just add the direction that it traveled. There's a couple different types of speed and velocity. There's average and instantaneous. Average speed is when you look at the whole distance traveled and divide it by the time it took to travel that whole distance. So, for example, maybe over the summer you drove to Florida on a family vacation. You would start your timer at the time that you leave your house and then end it at the time that you end up in Florida. And you would look at the odometer between the time you left your house and the time you ended up in Florida and divide the two together, and that would give you the average speed. Obviously, you weren't going that same exact speed the whole time. There were some times you had to stop at stop signs. There were times that you were on the interstate and you were going way above whatever you calculated. but that is the average speed. Now, if you want to make that the average velocity, just calculate the average speed and then say which direction you went. So you would, whatever number you come up with, you would say, I went that fast as an average velocity to the southeast. Instantaneous speed is what the speedometer tells you as you're driving. So that's the speed at a specific point in time. And velocity is the same thing, except also you'd have to include the compass direction. Some newer cars even tell you what direction you're going. So if you were traveling 55 and you had your cruise set, you could say, I'm going 55 and I'm going in this direction. Maybe you're going south, and 55 miles per hour to the south, that's your instantaneous velocity. So one example problem, if we go back to our original one that we had before, if we said that each block is 100 meters, and it took someone 250 seconds to run the whole path outlined on the map, what was his or her velocity? So if we look at this, there's 5 blocks, right? Remember that. So that's 500 meters that was traveled. That's the distance. And it said it took someone 250 seconds to travel that. So 500 divided by 250 is 2 meters per second. Most of the problems you'll run across will give you maybe from here to here, it's this long and it took this much time. And from here to here, it's this long and it took this much time. And they'll do that for maybe each of these arrows. And you might be asked to calculate just a portion of that and see what the average speed was for that little bit. Or you could be given all of those distances and have to add them up, along with all of the times for each of those blocks, and have to add those up and then divide the two to get the average speed.